recording. There we go. So essentially today, if we were to like to talk about, let's get to it. Let's get to it. Let's get to it. I think previously, if you have watched what we spoke about previously, we addressed the Duo 8, and today we're gonna talk about the pipe weight. And pipe weight, it has some it come across we come across it when we are dealing with pipe synchronization. Pipe synchronizations are essentially the wire tap, okay, the wire between two processes, or the communication between two threads. Um, that's the right thing. They are unidirectional. We need to have two entities holding the pipe in order to make it structurally accurate. A writer and a reader. That's it. Okay. So if at any point you come across a point where you have a single writer and you don't have a reader, we have a problem. If you have a reader and you don't have a writer, we have a problem. Or if they are present, but the other end of the pipe is not responding, then it becomes a problem. So what we have built is we have built a script that identifies what's happening between these two processes. Okay, but in most cases, if you come across a process and you say, "Hey, what are you doing?" and it says, "I'm waiting," the most fundamental thing is, what are you waiting for? If it's a well-written code, you should not have any trouble debugging what's happening or finding what the problem is under the hood. So that's just that. So let's get to it. So in this case, firstly, I'm gonna create the trouble and fix the trouble, and then fundamentally explain how we got to build the script to begin with. There we go. So for pipe, Python, pipe, I think we sandbox this lot to it. And then what are we looking for? Let's start with the healthy pipe. There we go. Now let's hunt for this other thing. Did we get a PID? No. So we need to hunt for that. Pgrep Python. Great. Now we have this right here. And if we are utilizing the script that we have used, so I don't know if you would most definitely get to say, hey, this process right here, it's blocked on this right here, okay, and you most definitely have to like find out what is happening, how to solve the issue. So in this case right in here, genuinely, so I hope you get a notification that says, hey, listen, this process right here, it's stuck on this right here, and you will most definitely have to find out what to do with that. And then somehow I genuinely feel like there should be like an automated system or daemon that deals with this. But and I'll say this: I've built one for, was it for close rate? I think it was for close rate, and what it did is I had like a very short timer, and so it kept hitting this driller. It increased context switching, and it was a lot. It caused havoc to the system, and the battery would drain like nothing I've seen before. And I already have like a battery problem, so that increased the problem tenfold. There was that. Anyway, so let's get into this. So here, what we're dealing with is we have, so firstly, we created the problem. Now we need to hunt for the problem. For the script, it's called the script is we look at the pipe. My hands up very cold, so my typing is going to be very slower than normal. Pipe hunter, right? Boom. My god. Right, so here what we have is, I don't know if whether this has anything to do with SIOC or anything like that, but that's the role that I'm really trying to get into. I'm going to build all of this right here, break and demystify the kernel or operating systems, because growing up, genuinely, I thought this thing was for the smart people. I thought it was just magic. But it's when you learn and you break things apart that you get to realize that it's not necessarily the case, right? It's just a well-built logical machine. Of course, it breaks here and there, like anything that we build, unfortunately, but we're here. So anyway, here is we managed to cause the problem and fix the problem. So problems, pipes happens. They're not necessarily frequent, but they do happen. I usually refer to them as silent killers or silent hangs, because they break apart and you don't necessarily get CPU is at zero. Why do we have the whistling sound? think if you watched our previous video, when we had this right here, we had two processes that were hitting. Let's have a look at that. 60 genome. Dude, I'm genuinely trying to let's figure out what's causing this right here. As soon as I have the reasons out, I know for a fact that I have a single process that is really thrashing a single CPU core. And if I pause this or terminate this process right here, everything goes down. Genome shell. OBS is very respectful. Firefox is doing what it needs to do. Very respectful. Let's see the user system 3.4. CPU system. Man. Alright, so there's that. Unfortunately, we scraped everything that we were looking at. Python, great. Now the script. There we go. So essentially we managed to cause the problem and now we're fixing the problem. And now it's telling you what is happening. So firstly, did we unblock the mouse? So one, this is the target process that we're looking at, okay? And not only that, but we're also getting the parent of the process. So we can definitely ask this, who started this right here? Come on. Is it running? That's slipping. But we already found out that's bash right here. So the parent process of this whole thing is bash. Yeah, anyway, so let's get into it. So initially, well, maybe I'll break it down when we get to like the manual part of things and how you could do this. But essentially, what this script does is it gets you the parent, the PID of the parent, right, or the very first process that you come across, and what it is currently doing. Unfortunately, instead of pipebrain, I don't know if it. I think I have a second script that literally says pipebrain, but in this case right here we have a timer, not a slip. Okay, so you have a process that is slipping, right on time, and the target, the pipe they're connecting to. So we have two processes in this case, process A and process B. Process A, this is the PID, and this is what it's slipping on, and it's connecting with process B through this pipe right here. Alright, target resource. This is the pipe that they're communicating over, what they are sharing. And here's process B, right? And this is the child. And not only that, but we get to find out what the child is up to. The child is sleeping. What is the child waiting on? The child is also sleeping. So it shouldn't be much of a trouble. If we have a process A and process B, they're both sleeping. I know sleep are they are working as designed. The process, whatever it is, it's working as designed. Not unless if it's a toxic slipper, meaning that it has like a very small interval. It keeps thrashing the scheduler, asking for attention or asking for whatever it is that it wants. Then it becomes a toxic slipper, and we'll get into that because we've already developed like a script that deals with it. Will identify the thrashing that happens to the system. But for now, peaceful sleep. Now, look at this right now. Okay, great. Let's terminate this right here. And now let's ask for a broken pipe. Right? And of course, we're gonna have to find the PID of the process. Did I do? PID of the process. Great. Now let's ask for the script. There we go. Here we had two processes that were sleeping. Diagnosis normal, idle timing, pipeline active, neither endpoint is currently stuffed or deadlocked. Now, here's when we have a broken pipe. We have the parent, okay, and we found the child. They're connecting over this single pipe right here. Right. Now, we asked for the kid. What is the kid doing? So we found the kid. What is the kid doing? The kid is asleep. What is he waiting on? Nanopipe read. So right here, we have two processes. We have a parent and a child relationship, you could say. More or less, it works like that. Or just two processes to say the very least. Here, we have a parent who is asleep, right? And a timer. Given the script that we have created. Otherwise, we should have a pipe waiting on a pipe. And then, but in this case, this makes sense. So we have a parent who's sleeping, then you have a kid who's sleeping, who's trying to read from a pipe, but it's empty, right? So this is reading on the parent. The parent is asleep. The kid is reading on the parent. The parent is asleep. The kid says, "Hey, listen." Tells the kid, "Hey, listen. I'm trying to do my work here. There's nothing for me." And the parent is sleeping on a timer. It's not necessarily deadlocked or whatever the case may be. It's just sleeping on a timer. So it's not necessarily a problem. It shouldn't be a problem. It could be a problem, but in this case, we're saying that it's not necessarily a problem. The problem is with the kid. The kid is trying to read from a pipe that is empty. Hence, the diagnosis is child starvation, abandonment, and then here, the child is trapped in a pipe, read because the target, of which is the parent, is asleep on a timer. There we go. I don't know if I explain this properly or break it down very nicely and neatly. I don't know. The problem is that what I'm saying is not scripted. And I feel like if it were to be scripted, it would be a lot less chaos or chaotic. But we'll get into that. I don't know. I'll figure it out later if whether that's what I want to do or I'm just gonna improvise and go with it and run with these things. But they are just very fascinating and interesting to break apart and understand and the script. There we go. And without the script, if you were, because I really started like doing these things manually. Firstly, you define the Python of the PID of the process. Okay, you ask, what are you doing? Come on. What are you doing? Sleeping. Okay, what are you waiting for? I'm trying to sleep. I'm sleeping. I'm waiting on a timer. I'm waiting on my alarm to go off. Okay, and if we needed to find the other end of the process, there we go. We have a single pipe. So if two processes are communicating, that's communicating over a pipe. It could be a socket. There's a lot. Okay, it's not doesn't necessarily happen over a pipe alone. If that is the case, then we use sudo find a process in the machine that is that has this pipe right here. Right. There you go. So find me find me a process in this machine that is running that has this pipe. Let's go see that. Boom. Right. And have a look at this right here. This is the very first process. This is what we found. This is where we found the pipe, and then now we're trying to find the at the end who's holding the pipe, and then we get 14775. Fortunately, when we said pgrab, we already got two processes, and this is exactly this proves it. And then you find this process right here. You ask, what are you doing? Sleeping. What are you waiting on? Right? Wait, or you could say sudo stack, and you will most likely get to find more or less the very same. Just that here it's better history, what the process has been doing up until now. Here's the current weight, right? Yeah, basically that's how you're going about it. For me, if there's anything that has helped me is the breaking down or the storytelling behind it. Let's find a process that maybe it's a parent and child relationship. In this case, right in here, you could say, I don't know if what it's perhaps synchronization. I don't think it has anything to do with it. It's not necessarily like a parent and child relationship. It's just two processes or two entities just communicating over a single wire. In this case, that's a pipe. I think what we are realizing or getting at is it's just things communicate, and they need to have a medium of communication. Be it's a socket, it's over the internet, it's over two entities, threats, processes, they need something to communicate, and those things that they communicate over, they with how they pass information, they break all the time, and we just need to find ways to deal with how structurally how is this crafted. We need to test if whether it's healthy, if information can pass through the wire, and how do we identify when they have broken apart. That's it. So for purpose synchronization, this is how you do it. So instead of manually going through every single thing, like in this instance right here, we would definitely default to the script and say, well, what's happening? And it will tell you, okay, well, this is the process, and this is the other end of the, this is the other end. This is the person who's holding the other end, and this is what they're waiting on, and this is the WeChat and the state, and most likely the conclusion. So I generally feel like this will most definitely have to update a lot of this right here because there's a lot. For the time being, this is it. Cheers. Good news.